Hello students, welcome to EPG Pathshala. I am Satwanti Kapoor from Department of Anthropology, University of Delhi. Today I shall be speaking on the module Role of Body Physique Assessment in Sports Sciences from the paper Applied Anthropology. The learning objectives of these modules are to understand how physique plays important role in sports, to understand how the profiles of athletes varies in different sports, to understand the methods of assessing body composition and physique among sports persons, and to understand the need for consistent data. First of all, we will discuss briefly about the importance of physique in sports. The assessment of physique is important as it can be used to ascertain an individual's readiness for sports participation and to prevent injury. Developing skeleton is less able to withstand the trauma and shearing stress which occurs in contact sports, example football, or in sports with repeated internal trauma, example long distance running, pitching, etc., as compared to a mature skeleton, subjecting the athletes to fractures and other injuries. The assessment of physique is useful to characterize the profiles of athletes in different sports. Therefore, an individual with a particular profile can be encouraged to participate in the sports for which he or she is physically best suited. Interest in the influence of body physique on physical performance dates back to antiquity. Physique of a sumo wrestler can be compared easily with that of a marathon runner or that of a volleyball player with a gymnast. It can be observed very well that within particular sports and position, the physique of elite athletes appear similar. However, the body size, structure, and composition differ markedly among athletes of different sports. An Australian Institute of Sports started a talent search program. They scored schools for 14 to 16-year-olds with the body type to be elite athletes. One of their first find was Megan Still. In 1987, she had never touched an oar in her life but had almost the perfect body type for a rower. After intensive conditioning, what I mean is intensive physical conditioning, she won a gold medal in women's rowing in the 1996 Atlanta Olympics. Now, body type. The relation of body composition to physical performance has been observed in adults, though they have focused on influence of body fat on running performance. Percent fat is significantly associated with poorer performance at distance ranging from 800 to 10,000 meter, R value 0.49 to 0.69 in trained runners. Brendan and Boileau, 1987. The human body can be divided into three different body types based on the structure and build, such as mesomorph, ectomorph, and endomorph. Now, mesomorphs are large boned and have highly defined muscles with a low, narrow waist. Men are rectangular and women are hourglass shaped. Ectomorphs are thin, lightly muscled with small wrists and ankles. Endomorphs are soft and round with shorter limbs, high waists, small hands and feet. Generally, most people are mixture of these three body types, but those who are mesomorphic tend to do well in sports as weightlifting, while running is where ectomorphs are found to excel. Anthropometry and somatotyping. Anthropometry plays an important role in athlete selection and performance criteria in sports. Determination of the somatotype is especially useful in sports in which the body may impact on the biomechanics of movement as well as performance. Investigations of somatotypes in elite sportsperson play an important role in the study of dynamics of development of a specific shape of the human body under the influence of various intensive purposeful training processes and competitive periods. It is well known that the anthropometric profile may indicate whether a player would be suitable to participate at the highest level in a specific sport or not. Somatotyping is one of the most valuable methods of evaluating body physique. It is the quantification of the present shape and composition of the human body in terms of endomorphy, relative fatness, mesomorphy, relative muscularity, and ectomorphy, relative linearity or thinness. Because of its exclusivity, somatotyping has been used for studying population variations and or age and sex variations. The differences in physique between populations in different regions were of importance, especially to underlie the cultural differences. Now, somatotypes vary between population groups as well as during growth in the same population. In growth studies, somatotyping allows one to characterize changes in physique during growth in order to monitor growth patterns and to better understand variations in adults. Now, changes in somatotype components during the growth period can also provide useful information about the growth status and the timing and the rate of sexual maturation. In a group of sportspersons, the wrestlers had largest body volume and were the fattest. In this module, Heath and Carter method is followed for evaluating somatotype characteristics. The following equations are used for calculating somatotype: endomorphy, where we use sum of triceps, subscapular and supraspinal skin fold, and height. This is called height corrected endomorphy and is the preferred method for calculating endomorphy. Mesomorphy involves biepicondylar humerus, biepicondylar femur, corrected arm girth, corrected calf girth, and height. Where corrected arm girth, upper arm circumference minus tricep skin fold, and corrected calf girth is calf circumference minus calf skin fold thickness. Ectomorphy is calculated using three different equations according to the height weight ratio, which can be calculated as height divided by cube root of weight. Somatochart using the formula given by Carter 1980, individual somatotypes were plotted on a somatochart by calculating values of x and y coordinate. X coordinate equals ectomorphy minus endomorphy. Y coordinate equals 2 into mesomorphy minus endomorphy plus ectomorphy. The values thus obtained are plotted in somatochart. Somatochart, which was first devised by Sheldon, is a schematic triangular shaped two-dimensional representation of the theoretical range of known somatotypes. The figure shows the distribution of somatotypes plotted as points and their concentration on the chart. Furthermore, somatotype dispersion distance, mean somatotype dispersion, standard deviation of somatotype dispersion distance have been calculated using Ross and Wilson's method. Body type analysis is useful for sports selection as well as helps for training. Although it seems certain body types are better suited to certain sports, there is still a considerable degree of you are what you train for, particularly found within certain parameters. This has been exemplified by research pointing to differences and anomalies within playing position in basketball and other sports. The relation of body composition to a physical performer has been observed in adults, though they have focused on influence of body fat on running performance. Assessment of weight and body composition gives us useful information for athletes. Training and nutrition is also useful in childhood and adolescence in order to appreciate nutritional status and monitor corrective treatment. Body mass index (BMI) is widely used for adults for clinical and epidemiological assessments. It is also defined as body weight expressed in kilograms divided by square of height expressed in meters square. Usually BMI is used to estimate one's normal weight, but body weight and BMI do not give information about body fat. Some well-trained people with muscle mass may have a high BMI scores but very little fat. There are people who are at the standard weight for age, sex, height or under this weight but they have too much of fat. There are also people, especially women, who have very low body fat tissue that is harmful for women. Now, body mass index is both influenced by fat and fat-free mass. Most of the heavyweight boxers are overweight according to BMI but are not fat. So BMI alone is not a good index for assessment of status of a sports person. Body composition. The body composition is a factor contributing to sports performance. Assessment of body composition is an important component of the ongoing monitoring of athletes interested in improving their performance. A two-component model of body composition divides the body into fat component and fat-free component. The total amount of body fat consists of essential fat, that is fat in the marrows of bone, in the heart, lungs, liver, spleen, kidneys, muscles and central nervous system, and storage fat, fat that accumulates in adipose tissue located around internal organs and subcutaneously. Body composition assessment for studying association of physique and several physical performance functions such as pull-ups, sit-ups, shuttle run, standing broad jump, 50-yard dash, softball throw, etc. Several methods are used for assessing body composition such as densitometry, hydrometry, body potassium, neutron activation analysis, creatine excretion and other muscle metabolites, basal metabolic rate and anthropometry. Several advanced techniques and methodologies have emerged such as bioelectric impedance and total body conductivity, dual X-ray absorptiometry, infrared interactance, magnetic resonance imaging and computed axial tomography scanning. Underwater weighing and DEXA, which is dual energy X-ray absorptiometry, are the only body fat testing methods that have been scientifically validated and thus are considered the gold standard. But they are expensive and impractical for most people and also for screening a large group of people. In sports practice, assessment of body composition is based on skinfold measurements. The skinfold method of measuring body fat is practical, economical, accurate and non-invasive. Results come close to underwater weighing and DEXA, but the technique requires much practice to obtain accurate results. Measurements are taken with a caliper at several body sites. Now, body fat percentage. Body fat percent varies considerably with gender, age among athletes and non-athletes. Essential fat is necessary for bodily functioning and essential fat in women is higher than that of men. The optimal body fat in adults, non-athletes, is 12 to 18% for men and 16 to 25% for women. The body fat percent for elite athletes varies largely by sports, 6 to 13%, 19% throwers and harder categories for men and 12 to 19% for women. Changes in athletes' body weight and body composition are correlated to state of training, training level and calorie intake. Now, excess body fat hampers performance, whereas fat-free mass or FFM is normally associated with enhancing performance. Most sports as well as training programs aim to reduce fat to a minimum and increase fat-free mass to an optimum. Excess fatness reduces performance as it adds non-force producing mass to total body weight. Acceleration being proportional to the force but inversely proportional to the mass. Excess body fatness at a given level of force application resists change in velocity. Velocity is an important component in many sports. Sometimes, however, certain level of fat located at specific level is important for certain sports. Body composition profiles of elite athletes in most of the sports which involve translocation of body mass, a low fat percentage is advantageous as far as mechanical and metabolic aspects are concerned. Fat-free mass has a positive relation with performance, whereas excess fat-free mass may be negative factor for some sports. A large fat-free mass is, however, required where force has to be exerted against an external object. A large fat-free mass may have a negative influence on performance which require translocation of body mass because it, like fat, adds to mass of the body, that is running, jumping, agility events. The present slide shows the ideal body type for a particular sport. For high jumpers, being tall and light, it is an advantage, but they also need strong muscles for power and lift. The ideal build for high jumper consists of ectomorphs with some mesomorphy. For a sumo wrestler, it needs to be heavy so that he is hard to push or be lifted. The main deciding factor is strength and power. Endomorphs with some mesomorphy is ideal for them. As for a gymnast, being light is an advantage. However, strong muscles are needed for lifting oneself and to hold a position. The ideal body build consists of ectomorphy with some mesomorphy. There are many studies which have suggested that person body fat is inversely related to maximum aerobic capacity and to distance running performance, and lean body mass seems to be positively related to performance in sports where the ability to generate maximum aerobic capacity is required. The athletes who has a very good lean body mass is able to have a high level of subcutaneous fat, like rugby throwers in athletics. But this growth must not associate with high level of blood lipids and cholesterol. Swimmers, especially female swimmers, have percent body fat higher than long distance runners or cyclists. In a sports like gymnastics, distance running, jumping, etc., the athletes must be underweight with good body mass and less body fat. The ideal body weight and body composition are essential in artistic gymnastics because the exercises are made against gravitation. Body composition and body fat is important for weight category sports as judo, wrestling, boxing, weightlifting, etc. In order to choose the realistic weight category, aesthetic sports such as gymnastics, diving, figure skating are in essence weight category sports as a low body mass and an ideal body composition are the requirements. Now, this module can be summarized as it is well known that the anthropometric profile may indicate whether a player would be suitable to participate at the highest level in a specific sport event or not. The quantifications of morphological characteristics of high profile athletes can be a key aspect of relating body structure to sports performance. On the other side, the quantified body physique of elite sportsperson has been shown to alter over time. Analysis of the latest literature comparing anthropometric variables and somatotypes clearly illustrates that specific functional requirements produce differences in the anthropometric variables of human body. Wide range of body size and composition characteristics among elite athletes demonstrate that physique plays an important role in high level performance in many sports. A lot of factors such as biomechanical, physiological, psychological and morphological play important role in sports performance. Body size and composition may enhance or limit performance in a particular event. Tall stature, for example, is very useful in sports like basketball, whereas a smaller stature is beneficial in gymnastics. Large body mass is important for wrestling, whereas less body weight is required for running. Human physique play an inseparable role during execution of movement, skill and technique. The quality of an individual's movement and skill efficiency in terms of its utilization value is directly proportional to his level of performance. Excess body fat hampers performance, we all know that, whereas fat-free mass is normally associated with enhancing performance. Most sports as well as training programs aim to reduce fat to a minimum and increase fat-free mass to an optimum. Excess fatness reduces performance as it adds non-force producing mass to total body weight. Acceleration being proportional to the force but inversely proportional to the mass, excess body fatness at a given level of force application resists change in velocity. Velocity is an important component in many sports. Sometimes, however, certain level of fat located at specific level is important for certain sports. Body composition profiles of elite athletes in most of the sports which involve translocation of body mass, a low fat percentage is advantageous as far as mechanical and metabolic aspects are concerned. There is a need and requirement for morphometric oriented studies in sports with an importance of differentiation by age and sex. Studies showed that the essential difference in the anthropometric variables and their somatotypes are because of the large age difference between groups studied. It also is difficult to make accurate conclusions on the morphometric and somatotype characteristics of elite athletes due to a lack of consistency between different studies based on data received from different national groups of athletes and obtained during differing periods. Thank you.